Alright, so for this problem, it says an insurance company purchased a perpetuity including a geometric series of quarterly payments for a price of 100,000. So this whole perpetuity due is going to equal 100,000, and it's based on an annual effective interest rate of I. The first and second quarterly payments are 2,000 and 2010 respectively. Calculate I. So they're saying that this due is worth this, but they're saying that these payments are quarterly. So what we're going to do is, well, firsthand, we are going to form a geometric series by finding out what the relationship is between these two numbers. So what I'm going to do is I'm going to take the later date payment of 2010 and I'm going to divide it by 2000 to see the geometric series that we are working with. 2010 divided by 2000, and we get 1.005, which means that each term is going to be 1.005 greater than the preceding factor. So now they're saying that the first, it's a perpetuity due, right? So now occurring here, the first payment is going to be 2,000. Then the second payment is going to be 2,000 times 1.005 or 2010. But since we're trying to form a geometric series, we're going to have to multiply the payment occurring afterwards by the growth rate of 1.005. Another thing is that we also have to discount it since it's a present value concept. Next format is going to be 2,000, 1.005 squared to b to the squared, right? And this series is just going to continue on over. Now let's try to actually solve this perpetuity due, right? So how do we find a perpetuity due involving a geometric series? Well, it's going to be first term minus 1 over common ratio. There is no first omitted term minus first omitted term occurring in the numerator because the perpetuity is an ongoing thing. It's not ending anywhere. So it's just going to be this equation. Now we'll notice here that the first term equals 2,000. 1 minus the common ratio. So what is the common ratio? It is 1.005b. Now we're going to set this equal to 100,000. Right? And we're going to find b. So what I'm going to do is I'm going to move this to the other side. I'm going to get 2,000 over 100,000 equals to 1 minus 1.005b. Now I'm going to do 2,000 divided by 100,000 minus 1 divided by negative 1.005. So I'm going to get that v is going to equal to 0.975124378. I'm going to keep all the decimals just to be accurate as possible. I'm going to set it to 1 plus I so I can actually find what I is equal to. But remember, this is the I quarterly because we're dealing with quarterly payments. So everything is in a quarterly format. So I'm going to convert this to 0.9. I'm going to keep this for short as of now. 0.75 plus 0.75 I equals 1, right? Then I'm going to do 1 minus 0.975124378, right? Okay, and then I'm going to divide it by 0.975124378. And I'm going to get I equal to 0.0255100204. So this is the quarterly rate. So I want to convert it to the annual. Quarterly payments occurring in 1 year. Yeah, let's solve. So I'll do this one plus 104 minus 1. And I'm going to end up getting I equal to 0.10601, which makes me, so it's 10.6 or so, which makes it answer D.